The next program which we're going to look at is called Objed. It's an environment for editing objects, or timbres, which are to be used in a composition. Like Scriva, the screen is divided into regions according to function. The uppermost region contains the data to be edited, that is, the data defining the timbral quality of the sound. As we move down to the lower left-hand side, we have a set of graphical potentiometers which are used in auditioning the sound in a particular context. Across from that, we have a control area where we can specify different modes that are used in the editing environment. And finally, to the right, we have a region which is used for saving and retrieving data. The program is based on a very simple premise. That is, to do anything, you need only point to what you're interested in and depress a button on the cursor. This simple strategy gives you access to the entire potential of the program. So let's probe the waveform. I'll point and depress the button. This brings us to a secondary panel, that is the panel which controls waveforms. The current waveform is displayed over the grid, but down the right-hand column we see a menu of alternative waveforms which we can select from. In fact, each waveform here is a separate file which is identified both by name and by contents in an iconic or graphical way. If I'd like to hear what a particular waveform sounds like, I first select it by pointing. It appears in the region where the sine wave was before, and I go to the Done button, which returns me to the main panel. Notice that no matter what I've done, the current state of the world is visually displayed, therefore reducing the cognitive burden on the part of the user. Now, a consistent manner can be used at any point to audition what we've done. So if we'd like to hear what this particular waveform sounds like, I need only point to the light button called play, depress the button, and the sound will appear. The sound which we heard was at a default pitch, default volume, and default duration. To change the context in which we are auditioning this sound, we can move down to the lower left panel. Here we see a set of 3 graphical potentiometers: pitch, volume, and duration. Any one can be adjusted in an analog fashion by just pointing and dragging it up and down. Let's take a more complex example. This time what we're using is a technique of sound synthesis known as Fourier synthesis. That is, we specify the amplitude and frequency time varying information for the harmonics from the 1st through the 16th of the sound. To specify the amplitude contour of a harmonic, I point to the harmonic number, depress the button, and simply use rubber band lines. The dimensions of the screen are time from left to right, amplitude on the y-axis, and the z-axis coming towards me are the harmonics 1st through 16th. We can add some third harmonic. And when we're ready, we can come down to the play button and audition the sound which results. Now, like in Scriva, one of the key things about an editing environment is flexibility in the notational scheme. Now, here's a good example. Sometimes it's useful to be able to see the partials laid out in this type of pseudo-3D notation. But sometimes it's not. For example, if I want to synchronize the functions in time, I point to the little box here at the end of the z-axis, and I can reorientate the z-axis as follows. Pick it up, release it, and suddenly all the partials are aligned in time, and yet I can still see them. I can still define the 4th harmonic if I like by pointing and sketching. And furthermore, if I want to trace one function from another, I can bring the origin of all functions over a single point, as follows.